Kirtana, in the studies class, I told we had discussion about grouping of cells in parallel combination, right?
In series combination.
Yeah, like we had a series combination. Okay, so today I'll be teaching you about parallel combination. Okay, so let's start the things. Grouping of cells in parallel. Okay, so look, whenever you do so, you have to look for the parities. Assume, Kirtana, I have given you this kind of circuit. This is R1, okay, this is E1, and this is E2, this is R2. I want to make a circuit or some equation such that I can replace this with some equivalent, and it should be R equivalent, okay? So we know that Kirtana, R equivalent will be nothing but because look, series, the resistance in the series, right? You can simply say R1, R2 divided by R1 plus R2. Okay. Now we have to calculate E equivalent, okay? So let's assume Kirtana, because I told you you can assume any one putting as a zero, okay? So assume this is a zero and this is a x, okay? I don't know what is the values, just assume it for a while. Our task is to Kirtana calculate x because what is the net potential across A and B? You can say that is x minus zero. So that will result you the net potential across these two terminals, okay? So can we do one thing? Let's apply the KCL equation at this particular terminal x. So that is coming out to be x. Okay. So Kirtana, if you look at this, what is the current going? You can say that whatever the current it is going in this way, that is nothing but potential this minus this. So can I say this is x and you are going from higher to lower, basically this point, right? So want it be x minus e1. So this will come out as x at x minus e1 divided by r1, basically this one, plus x minus e2 divided by r2, that comes up as 0. So if you just resolve it now, when you are solving it, you are going to get 1 by r1 plus 1 by r2. Okay. So here now if you look at this equation, isn't it the equation for this is x? Okay. X is just a potential value. So this comes out as E equivalent E1. This is E1 by R1 plus E2 by R2. So this will become as 1 by R1 plus 1 by R2. Okay. Where your R equivalent will be uh, R1 in a parallel combination with R2. Basically, you know how to solve it, right? R1, R2 divided by R1 plus R2. So if I ask you for n cells in parallel, how what it will be? E equivalent will come out as E1 by R1 plus E2 by R2 plus E2, whatever the number is there, okay? So on, E by R3 or Rn. It should be divided by 1 by R1 plus R2 plus 1 by R3, so on. Look at this only you can do if all have a resistance. Okay, because if you see any combination is there. For example, if I gave you circuit like this, but at this part you don't have any resistance. Okay, let's say there is no resistance. So you can't apply this formula. That, okay, you have to neglect this one. Simply apply for the upper ones where have resistance. The one which don't have resistance, you can directly solve it. Okay. The reason is if you do so, you'll be putting because there's no resistance. It means resistance is zero. When you put resistance is zero, basically you are putting one by zero, and that is not defined, right? So that's why you can't do in this case. In these cases. So you have to take care about this. And one more thing, for example, if you see this is E1, E2, right? If you see the parities change, for example, here higher to lower, you can simply add them, okay? But the moment you get opposite parity, basically you are to have, so you have to let, for example, if you are assuming these one to be positive ones, okay, and this is basically E2, so you have to like E3, so you have to keep it negative. That is what you have to take care of. If parity changes, your sign convention is supposed to be changed. And that depends upon the relative sign convention. If you are taking this direction as positive, this is supposed to be taken as negative. This is a parity which you have to take. Okay, so Kirtan, I'm giving you one problem, a battery grid. Basically, when I'm saying a battery grid, this is a long lengthed wire. Basically, you have connected lots of battery in between. Okay, I mean that you have something like this: E R E R E and another R and so on. Okay, and in the same way, you have these many things and so on. In the horizontal, you have total n batteries and n cells, basically one, two, three, and so on. You have at last as En, okay, and Rn. And in this way, this is one, this is two, and so on. You had m times. Finally, you have this, so on. This. So basically, you can say that total m number of rows, m rows basically, Kirtana, this one is one row, two row, and so on. You have m times of rows, and in each row, n cell and resistors. This is B terminal, this is A terminal. Calculate um, equivalent voltage across A and B. Okay, yeah, you can just try to solve this and get me the answer. All right. Solve it and get me the answer.
Plus thought.
Yeah, kids. Now, how much you got? Kids, have you got the answer?
No, sir.
Just try to look, do one thing. I can give you hints for this one. First, try to solve the series one, then go in a parallel one. Okay?
Sir, is it MEN divided by 1 by R?
How much you have got to ignore also?
MEN divided by 1 by R.
The answer should be like I can't say it properly, but the answer should be N R by N. Is it the answer?
Sir, can you solve it?
Yeah, sure. But if you see in the series case, what you're getting is you're having n times, right? So you can simply say that P equivalent in series is equal to n times of P because all of them are same and n times of R, right? When you take the same thing into the parallel, how you're going to get is now you have n times of parallel combination where you have HP, NR, okay, and the same thing is n times. So what I do is when you have a parallel, what you have to do simply NP by INR plus NV by plus NV by N1 plus NV by N1 so on. So divided by how much is that? 1 by maybe N1 plus 1 by N1. So you can simply go and say that what is the answer? You can say this helping to know what we will do. Keep doing this again with n times v by r divided by this portion is how much? 1 by maybe what it should be 1 by n r. So um, is it clear? I thought to find I was maybe one correction should be there. So this will get cancelled out. This is also valid. If yeah, equivalent should be this. Will be only R equivalent is supposed to be how much? And R by. Okay. This should be now. Just check it once if you get it with your opinion, if it's clear. You'll have to no, no, sorry. It should be, if you see carefully, I have got these things and cancel. It should be coming for this and then cancel out, we will be getting cancel. The final across A and B will be n times of P and it will be how much n R by. This is what we are supposed to. This will be E equivalent, okay? E equivalent R equivalent. Please clear it like if you have any doubt. Hello, Krishna. Can you Krishna, look there? I think there's a network issue. I'll be sharing you some problems, okay? I will disconnect the class now because due to network, it's not going good. I will share you some problems. You can try those, okay? Is that clear?
Yes, sir.
Because look, yeah, I'll be sharing you 5 to 10 problems. You can try those after the class because there's a lot of network issue. I'm not able to continue. All right, Kirtan, I'll be sharing this part, okay, as a PPT. You can exit the class, okay? If you want, you will get the PPT. I'll be adding some portion over here in this slide itself, okay? Okay, Kirtan, goodbye.